All right, your opener here wants to know how many degrees there are in your circle. And we should know by now that when you spin around a circle, you do go 360 degrees. It does not matter how big that circle actually is. Right? No matter how big that circle is, it will have a total of 360 degrees in it. Now, what we're going to look at today then is just looking at a portion of that circle then. Right? Now, when I do a portion of that circle, right? When we want to know how much of it we have, we're talking about how much of this piece of pizza, or that pie, that you're going to pull out, right? That angle that is in here, that is what is known as a central angle. It is an angle whose vertex is at the center of your circle. So here you're looking at angle ABC being a central angle. When you look at a central angle, it creates two separate pieces of your circle. It creates this piece inside the angle, and it creates this piece that is outside your angle. That piece that is inside your angle will be known as a minor arc. Any arc that is less than 180 degrees. Now, when you name that minor arc, we are going to name it using two letters. We can call it arc AB here, or if we wanted to, we could call it arc BA. It's that same arc, just like naming a segment would be. All right, so if I wanted to know the measure of arc AB here, we are looking at an arc here that is 60 degrees. Now, some people do try to make the argument, well, can't I go from A to B this way? And yes, you can, but you no longer make a minor arc. You make instead what we call a major arc. If I want the arc that is bigger than 180, my longer way around, it is not known as a minor arc. It will instead be known as a major arc. And when we go to name it, we cannot name it with two letters anymore. You have to name it with three instead. Anytime you name an arc with two letters, you are going to assume you are going the shortest distance between those 2 points.
If you were a member of the victorious Santos Senoras or Santos Sanitizers,
so your major arc,
you should be in the main lobby right now,
is an arc whose measure is greater than 180 degrees. And once again, you will name that using 3 points. So here we are looking at arc ACB, for example. Or any other point that was there. If you want to call it ADB or AEB, AFB. Right? But we always use 3 letters. The A and the B will still be there. And then you name some other point in between them to show you are going the long way around. A semicircle, then, is exactly half of your circle. It is an arc whose endpoints are the endpoints of your diameter. So it's an arc whose measure is 180 degrees. We can look at arc ACB or arc ADB being 2 different semicircles if AB is the diameter of your circle here. Now, the other thing to worry about then, when you look at a central angle, that central angle creates our minor arc AB. I'm sorry, in this case, AC. A central angle, that 50-degree angle there, it will be equal in measure to the degree of your arc. So we would say the measure of arc AC is also 50 degrees. There we go. When we measure arcs and angles, a central angle is equal in measure to the measurement of its corresponding arc. So it'll be equal in measure to that arc that it makes. So the measure of angle ABC is equal to the measure of arc AC. So when we measure those angles, now a semicircle then, a semicircle is made by a straight angle. That measure that straight angle would be 180 degrees, so the arc it makes would also be 180 degrees. So your arcs of a semicircle will be 180 degrees also. Take a look at your first example then. It says, find the measure of each arc in circle C. Where DF is the diameter, make sure you name and show its measure. So we can start with arc ED here. The measure of arc ED is equal to the measure of the angle that makes it. That would be angle ECD, so it is equal to 117 degrees. Now remember, DF here is a straight line. So it would have to be 180 degrees. That means the measurement of angle ECF here, this angle here, would have to be 63 degrees. So arc EF will also be 63 degrees. We could look at arc DF here, being a semicircle. So it would be 180. We could look at arc DEF, going the other way, being another semicircle. So it would be 180. Now, there are other arcs that we can look at. There are major arcs that we could use. We could look at arc F, D, E. Arc DF we said was 180. The DE we said was 117. So arc FDE will be 180 plus 117, which gives us 297 degrees. Now we can come around the other way also. We could look at arc EF, which we had already said was 63 degrees, and then come around to D. So add the 180 to that. So we got arc EFD will be 243 degrees. All right, so those are some of the different arcs we had in that picture. Looking at your next example there. It says find the measure of arc RTS. R around to T, around to S. Well, TS is a semicircle, so it's 180. If angle RPS is 45, that means angle RPT would have to be 135 degrees, because those two angles form a linear pair. That makes arc TR also 135 degrees. So I have my 135 plus my 180 gives me 315 degrees. Now that idea we did there, putting your arcs that were next to each other together, we have done multiple times this year. We did them in segments. We called it segment addition, where my AB and BC told me that AC, if I take my 3 plus my 4, it tells me AC would be 7. We used it with angle addition. If my angle was 20 here and 30 degrees here, we could say my big angle was 50 degrees. That was known as angle addition. Well, now we have another. It is known as arc addition. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs that make it. So if I look at arc BAC, I can take arc BA plus arc AC to get arc BAC. So take a look at finding those arcs that are here. It says you join a new bank and divide your money several ways as shown in your circle graph at right. Find the measure of your arc BD. So B to D, I can go two different ways. Do I want to go clockwise or counterclockwise? Since they name it with two letters, I must go the shorter way. So arc BD will be my 55 plus 105. So arc BD is 160 degrees. Arc BCD, that is my major arc. That is our 140 and our 60. So it is 200 degrees. That's how I know the difference. Is it named with two letters or three? Three, they tell you the direction to go. You got to go BCD. With two letters, you must go the shortest way. All right, that brings us to our last idea today. Talks about the arcs being congruent. That term congruent means that everything about them is the same. You're going to find there's two ways that we can talk about an arc. We can talk about the measurement, how many degrees it is, and we can talk about the length it is. How far you would walk if you walked that curve. Right? If you walked around a circular track, how far did you walk? Right? As a wheel turns completely around and makes one rotation, how far did the car travel? Right? How long it is. In order for your arcs to be congruent, the measurements have to be the same, and the size of the circle they come from has to be the same. So the degrees is out of 360, and then we need to know how long it is, that those lengths are the same. Right? So here we know the measure of arc AB would be 50 degrees. The measure of arc DF would be 50 degrees. And then the size of the circle is the same because that radius is the same in each. So here we have congruent arcs. Their measurements are the same and the size of the circles are the same. Whereas here, yes, the measurement of both of these will both be 50 degrees. But if you notice, the size of the circle is not the same. So the size of my arc here, they are not going to be the same. Right? That's how we tell. So if you look at your examples then, arc BC would be 75 degrees, arc DE would be 75 degrees, and then it's coming from the same circle, so the size of the circles are the same. So are they congruent? Yes, they are. Right? In our next example, we have that central angle being 80 degrees, so arc AB will equal 80 degrees. Arc CD will also equal 80 degrees. However, my two circles are not the same size now. So yes, we had the equal arcs, but they are non-congruent circles, so it will not work. And that third one here, arc FG is going to be 90 degrees. Arc HJ is going to be 90 degrees. And then the size of the circles are the same. We know that because the radius in each is the same size. So here it will be, yes, we do have our equal arcs, and we have our congruent circles. Take a look at your next one there. It says, in example 2, which was the pie chart that we had, it says, find the measure of arc BCA and arc ABC. So, BCA means I start at B, go around through C, and end up at A. So I have 140 plus 60 plus 105. So we get 305 degrees. For arc ABC, we start at A, we go through B, we end at C. So I have 55 plus 140. gives me 195 degrees. All right, last question then. It says in your diagram, is PQ congruent to QR2SR? So here we don't know the measurement of them, but since my central angles are congruent, the measure of arc PQ will be equal to the measure of arc SR. And then they come from the same circle. So we do have our equal arcs, and they're from the same circle. So our answer would be yes. Which brings us to your homework then. Pages 661 to 662, the numbers you see here. All right, if you have questions, please reach out and let me know. Other than that, please have a good day.